Now stop. Another catchy mathematic rhyme like go student, go student, go student. Wait.
Hello and welcome to the Kearney Math Show. Thank you for tuning in today. On today's episode of the Kearney Math Show, we are going to be featuring something called the remote interior and exterior angles. And this is actually an 8th grade standard. But I am not worried at all because I know that you guys are going to take what you already learned on Friday and apply it to what we're learning today. So before we get started, go ahead and write entry number 3 at the top of your mini lesson and read your learning goal. Okay, so our learning goal is that by the end of today, I want you to be able to explain how you can find a missing angle by using the exterior angles theorem. Okay, so you're going to actually be able to figure this stuff out using what you already know from the 7th grade standards, but I want you to be introduced to something called the exterior angles theorem. Before we get started, let's just talk about just some vocabulary, just so when I'm saying these words, you understand what I'm saying. So the first thing is, what do we call two angles that share a common side and a common vertex? And this is when I explained a few days ago, I explained that Miss Wilkinson's room was beside mine, and we could say that we were what to each other, or Miss Neighbor's room is beside mine, and I said we could say that we were what to each other. So what do you call two angles that share a common side and a common vertex? That's right, adjacent angles. Okay, so two angles that share a common side and a common vertex. For example, we have angle ACD, so angle ACD, and we also have angle ACB. Those two angles are adjacent to one another. They're beside each other and they share a common side and a common vertex. So if you look at the picture that I have drawn there, you see that there are a couple of different things going on. First, you see in the examples, you see a triangle. And then you see it looks like one line, like maybe the base of the triangle has been extended. And what has happened is there's an angle that has been formed when an extension is made of a triangle. This forms an adjacent angle. So basically we had a triangle, and then we extended one side. So we've created this, something called an exterior angle. So we know the word exterior. When we talk about the exterior of something, we just usually mean the outside. And that's exactly what has happened. We've created an outside angle outside of the triangle, and that's created some adjacent angles. Now, if you look at this picture, again, you notice that there are several angles that have been formed. We've got all the angles in the triangle, and so we've got our triangle here. We've got our exterior angle, and then we have these two angles inside that aren't, so these right here, that aren't adjacent to that exterior angle. Okay, so what those two non-adjacent interior angles of the exterior angle created when one side of the triangle is extended, those are called remote. Because if you are remote from someone, that means you're removed. So remote interior angles. So these two angles, let me just kind of show you here. These two angles here, this one and this one, because they are not adjacent to my exterior angle that we created. So they are remote interior angles. Okay, so our three big words. Adjacent angles are beside each other. Exterior angle is what happens when you extend a line outside of a triangle. And then those two angles on the inside of the triangle that are not adjacent to the exterior angle are known as remote interior angles. Okay, so we're going to take what we learned last week when we were talking about inside of a triangle to try to find some missing angles. So if you go down to example 1 here, what did we talk about on Friday? What did we say that all the angles in a triangle add up to? What should all the angles in a triangle add up to? That's right, 180. So we can actually use that to try to find this missing angle. So if you see in example 1, they've given you the 2 remote interior angles is 55 and 60. And they're asking us to find that exterior angle X. So take what you know and see if you can figure that out. So for me, what I see is I'm just going to look at the triangle first. Okay, and I know that all the angles in a triangle should add up to 180. So if I take the 2 that they've given me, 60 and 55, so 60 plus 55, I get 115. Okay, so I know that I've got to figure out what this angle will be here that would then add up to 180. So I can work backwards and I can say 180 minus 115. And I actually get that this interior angle should be 65. So now I've got all 3 interior angles. And what do you notice that 65 and X form with each other? What do you see that they're on top of? That's right, they're on top of a 180-degree line. Okay, just below, we're not really looking at the triangle anymore now, we're just looking at this line here. We see that's 180 degrees. So I've got to say 65 plus what would give me 180. So I can work backwards and I can subtract 180 minus 65, and I get the angle X is 115 degrees. Okay? So now, we're going to take and we're going to use what we learned and we're going to try to figure out how to do example 2. So example 2, they're asking for now 2 different angles, so angle V and angle X. So for me, my method of attack would be to maybe start with that exterior angle first. Okay, so you want to take a minute and try to figure out if you can figure this out. Okay, so I'm going to use this exterior angle, and I know the exterior angle is 92. And that means 92 and V are on top of a 180-degree line. So I can use those 2 to try to figure out what that V is. So I can say 180 minus 92 to figure out that V is actually 88. So this one's 88. Okay? And now, can I use 88 and 50 to find X? Yeah. I know. What do I know that all of the triangles, what do all angles in a triangle add up to? 180. So I can use the 2 that I know to find the missing angle. So if I work 50 plus 88, so the 50 and the 88, and then work backwards and subtract that from 180, I get the angle X. So 50 plus 88, so work that out, 50 plus 88 is 138. And then I can work backwards and say 180 minus 138, and I get that the interior angle is 42. Now, how can I check to make sure that is right? How could I then figure out that my answer is right? That's right. I can take all 3 of those and add them up, and I should get 180 degrees. Okay. So now what I want us to do is I want to take what we just discovered. I want to put it in the table just below. And we're going to try to figure out if we see some kind of connection. Maybe there's a pattern that might help make this a little bit easier for us. So if we fill in this chart, so example 1, it says the remote interior angles were 55. So I'm just taking this from up here. So 55 and 60. And then it said the exterior angle. So we found that to be 115. And then example 2, the 2 remote interior. Now remember, remote interior, there's 2 angles on the inside that are not adjacent to that exterior angle. So these 2. So we've got in example 2, 42 and 50. And my exterior angle was 92. So what I want you to do is I want you to take a minute to consider this question. The question says, what relationship do you see between the measure of remote interior angles and the exterior angle? So what I'm asking is, what relationship do you see between these two remote interior angles and their exterior angle? Do you see any kind of connection? Perhaps look at the next one, 42 and 50. What's the connection between 42 and 50 and 92? What relationship do you see? So for me, I see that the exterior, exterior angle 92 is actually the sum of the two remote interior angles. 42 plus 50 gives me 92, and I also see that 115 is the sum of 55 and 60. So the exterior angle theorem states that the exterior angle is the sum of the two remote interior angles. Okay, so that's my rule, is the exterior angle is the sum of the two remote interior angles. So if I know that, that would probably make my life a lot simpler. Like, for example, if I go back up to example 1, it's asking me to solve, so let's come back up here, example 1, it's asking me to solve for that angle x. So what I could do is I could just add 60 and 55 and know that my exterior angle is 115, okay? So in the next problem, I'm just going to help you get it set up, and then I'm going to let you solve. So it says in triangle PQR. So I'm going to draw a triangle PQR. The measure of angle Q is 45. So this one's 45. The measure of angle R is 72. Find the measure of the exterior angle at P. So it says, let's make this an exterior angle. So I'm looking for X. So what do we know that the remote interior angles and that exterior angle have in common? So use your rule and see if you can find that exterior angle at P. All right? So our one big thing that we're taking away from today is that the exterior angle theorem states that if you have a triangle and you extend one side to make an exterior angle, that the sum of the two interior angles will give you the exterior angle measure. Okay, so write down any questions you have, and I'll be happy to answer them when you come to my station. You can go ahead and use this theorem and try to solve those next couple of practice problems. All right, good luck, guys. Peace out, Rainbow Trout. Love you, mean it.